In this section, we'll be looking at examples where we use the addition and subtraction formula to evaluate trig functions and also verify trig identities. Let's go ahead and look at an example. Let's find the exact value of cosine of 105 degrees. And the first thing that we're going to notice is that we can rewrite 105 degrees as the sum of 60 plus 45. Let's rewrite cosine of 105 degrees as a sum. And now we can rewrite this using our addition formula. And so we'll get that this is going to be equal to. Now we know how to evaluate sine and cosine at 45 degrees and 60 degrees, which means we can go ahead and replace cosine of 45 degrees with 1 divided by square root of 2, replace cosine of 60 degrees with 1/2, replace sine of 45 degrees with 1 divided by square root of 2, and replace sine of 60 degrees with square root of 3 divided by 2. Simplifying this, we'll see that this is going to be equal to the square root of 2 divided by 2 times 1/2 minus the square root of 2 divided by 2 times square root of 3 divided by 2. And simplifying this again, we'll see that this is the square root of 2 minus the square root of 2 times square root of 3 divided by 4. And so our solution to this problem is that the cosine of 105 degrees is going to be equal to the square root of 2 minus the square root of 6 divided by 4. Let's try another example where we evaluate a trig function using our addition and subtraction formulas. In this example, we want to evaluate tan of 7 pi divided by 12. And we want to break this up into angles that we know how to compute. Then rewrite this 7 pi divided by 12 to be the following sum. We can reduce this even simpler. This is going to be equal to pi divided by 3 plus pi divided by 4. So to evaluate tan of 7 pi divided by 12, we're going to rewrite 7 pi divided by 12 as this term over here. Rewriting our 7 pi divided by 12, we'll get that this is then equal to tan of pi divided by 3 plus pi divided by 4. Now, using the addition formula for tangent, we see that this is going to be equal to the following equation. And let's just go ahead and evaluate tan of pi divided by 3 and tan of pi divided by 4. So tan of pi divided by 3 can be given by the following right triangle that has an opposite side length of square root of 3, since the acute angle is again given by pi divided by 3. The adjacent side has length 1. So tan of pi divided by 3 is just the square root of 3. Now evaluating tan of pi divided by 4, we'll get again a right triangle who has opposite side 1 and adjacent side 1, since this angle here is 45. So tan of pi divided by 4 is just 1. So filling in what we have now, this is equal to the square root of 3 plus 1 divided by 1 minus the square root of 3 times 1. Now to simplify this down, we'll multiply the top and the bottom by 1 plus the square root of 3. Then, foiling out the bottom, we'll get 1 plus 3. Oops, sorry, that should be a minus 3 here. Up top, we'll get the square root of 3 plus 3 plus 1 plus the square root of 3. Simplifying this, our final answer should be that tan of 7 pi divided by 12 is going to be 2 square roots of 3 plus 4 divided by a negative 2, which does simplify down a little bit further. This is going to be equal to the negative square root of 3 minus 2. Let's go ahead and verify the following identity, that the cosine of x minus pi divided by 2 is equal to sine x. First, rewrite the left-hand side down. Again, this is going to be just the cosine of x minus pi divided by 2. And since we have this x minus pi divided by 2, let's go ahead and apply the subtraction formula. This is going to be equal to cosine x times cosine of pi divided by 2 plus sine x times sine of pi divided by 2. This is going to be equal to cosine of x. Cosine of pi divided by 2 is 0 plus sine x times sine of pi divided by 2, which is 1. And we see that this is just sine x. Let's do another verification problem, and we're verifying that sine of x minus pi is equal to a negative sine x. Again, we'll start off by rewriting the left-hand side, and we'll get sine of x minus pi. And we can apply the subtraction formula for sine now, and this is equal to sine of x times cosine of pi minus cosine of x times sine of pi. This becomes sine of x times a negative 1 minus cosine of x times 0. And this simplifies to be just a negative sine x. Let's look at one more example where we're asked to verify a trig identity. And we want to verify tan x minus tan y is equal to sine x minus y divided by cosine x times cosine y. And what we notice is that there's nothing really we can do on the left-hand side, but we see this sine of x minus y, so we want to go ahead and simplify the right-hand side. So rewrite the right-hand side. This will give us sine of x minus y divided by cosine x, cosine y. Now apply the subtraction formula for sine, and this is going to become sine x cosine y minus cosine x times sine y, all divided by cosine x and cosine y. Now rewriting this as fractions, this becomes sine of x cosine y divided by cosine x cosine y minus cosine x sine y cosine x cosine y. And we're going to cancel out the common terms. We can cancel these two out, and we can cancel these two out. And what we're left with is that this is a sine x divided by cosine x minus sine y divided by cosine y, which is equal to tan x minus tan y. And we just verify the identity.